Hello. So today we're going to look at small angle approximations, and again this is really key that you firmly hold in your mind that this is only possible in radians. So this does not work when we're working in degrees. So here we have the graph of y equals sine x in blue. Now it's only part of the curve. This is where it's a maximum here. So if I was working in degrees, that would be where x is equal to 90. But I'm not working in degrees, I'm working in radians. So that point there is pi over 2. And equally this point back here is negative pi over 2, where the minimum happens. And what you'll notice is this here is the value 1, because pi over 2 is, just over 1.5. So here this is 1. So we are looking at smaller values along here because we're working in radians. I'm saying it again because I need that firmly in your mind. We're working here in radians, we're not working in degrees. And you can see that these values along this x-axis would be significantly larger if we were in degrees, because this would be 90, and here we'd be looking at this being perhaps about 60 degrees, maybe 70. These are big values, 60 and 70. But we're looking at very small values for the angle x. And what we notice is when they're small, so when we're here, the values of y equals x is very similar in this area here and actually to there. So if I'm looking in this section here, then y equals x and y equals sine x have the same values, but that only happens when x is a small value, okay? And therefore what we can say from this is that y equals x and y equals sine x are the same for these small values, and because of that we can say that x equals sine x, though I would say it's approximate, so that makes those lines wibbly for small values of x. What is a small value of x though? Well, it's a value that's close to 0. That's as good as it really gets mathematically. There's not a set point where we say this, but we're looking at values that are close to x. So we can say for those small values that x is equal to sine x. And just to say that again, rather than saying x equals sine x, I actually should be saying x is approximately equal to sine x for small values of x. It's important that it's said correctly. So we can go on and we can prove all of these, and actually we don't need to. If you do want to look at that, do look it up, do look in your textbook as well. But the key things you need to know are shown here. Sine theta is approximately equal to theta, tan theta is approximately equal to theta, and cos theta is approximately equal to 1 subtract theta squared over 2. Now there was a change in the Edexcel formula books to initially this was not in there and then it was put in. Can I ask you to go and check your formula books now so that you clearly know whether it's there and in your formula books, and make sure you know where it is, because in exam situations this is something that people don't know where it is in their booklets, and then they come out the exam and they haven't been able to do the question. So it's really important understanding where that is in your book and doing that now. So here's a type of question that you could be asked, and it says, when theta is small, find the approximate value of sine 2 theta add tan theta divided by 2 theta. Notice we've got these double angles coming in, and here are the formulas that we can use. So the key thing here is that theta is small. So starting with A, I have sine 2 theta, add tan theta, over to theta. And sine 2 theta, well, sine theta is equivalent to theta, so sine 2 theta would be equivalent to 2 theta. Add tan theta, which is theta, divided by 2 theta. So this would give me 3 theta over 2 theta, which is the same as 3 over 2. So there's my approximate value for when theta is small, because remember this is only when theta is small. Quite simple, good. And B, cos 4 theta, subtract 1 over theta sine 2 theta. So cos 4 theta, so notice it's 4 theta, it's not theta, and I would write 1 subtract, and instead of the theta I write 4 theta, and all of that is squared over 2. So I'm just going to put a bit of a circle around that so that we can compare it, and that we just check 1 subtract, instead of theta it's 4 theta all squared, and it's the 4 is squared as well as the theta all over 2. Subtract 1 all over theta multiplied by sine 2 theta, which for a small angle approximation I can write 2 theta. So from here what I can say is there's a 1 there and there's a 1 there. It's subtracting 1 there, so that would go to 0. And 4 theta all squared is 16 theta. So this equals subtract 16 theta squared over 2 divided by 2 theta squared. So that would become negative 8 theta squared divided by 2 theta squared, which is equal to negative 4. Now, if you have the textbook that goes with this, you may have the version where the answer is wrong, because they have written in their textbook that it's 4. It's just a misprint. These things happen in textbooks. I just wanted to clarify that in case you are looking at the textbook at this time. So moving on again, the last example we're going to look at is show that when theta is small, that sine 5 theta plus tan 2 theta subtract cos 2 theta is approximately equal to 2 theta squared, add 7 theta, subtract 1. So I do need my small angle identities, so let me add those in. So there's my small angle identities. So I have sine 5 theta, add tan 2 theta, subtract cos 2 theta. And for this, I can say that's equal to, well, approximately equal to, let's get that sign right, 5 theta, add 2 theta, subtract 1 minus theta squared over 2. So 7 theta, subtract 1, subtract, oh, do we see what I've made an error of doing? Just in there, let me just go back there. Because this is 2 theta here, this should actually be 2 theta squared over 2. So here, this would be plus 4 theta squared over 2. So therefore, what I can now write as my answer for this is 2 theta squared, add 7 theta, subtract 1, which is the answer we were looking for. So you can see how even I made that slip there. I didn't take the 2 theta and put it in, which then would have made this me not getting the correct answer. So let's look at the final part of this question, which says, hence, state the approximate value of sine 5 theta plus tan 2 theta minus cos 2 theta for small values of theta. Well, for B, if we're saying small values of theta, we're saying that it's very close to 0. And we've got this, and if theta was very close to 0, this first term, well, that would be nearly 0. This term here would be very close to 0. So I've really got 0 adds 0 now. And I'm taking away 1. So therefore my answer would just be -1. And again, that's because this is only for values that are very close to 0. So we can say approximately this here can be written like this. And because the theta is very close to 0, it's small values, we can actually say that this here, -1, is the answer. And that's small angle identities.